right, we're now going to kind of look at the another relationship between exponential functions and logarithmic functions. We're going to look at it using the graphs of these. So if you look at our first example, we're looking at the graph of f of x equals 4x. And just like we've done in previous units, we want to look at the domain first. So the domain, again, is going down your x-axis here, right? And if you notice, there's no fence. Like this is going up and to the right slightly, and it's going to keep doing that. It doesn't really build a fence here. Okay, so that's the difference between rational functions and exponential functions. So our domain for our exponential function is negative infinity to infinity. Okay? Our range, on the other hand, does have this fence, this horizontal asymptote here. So if you notice, there's nothing down here. So this whole part isn't part of the range. Our range starts here at 0 and goes up from there. So our range for this one starts at 0 and goes up to infinity, and that's it. Okay, it has nothing down there. Our y-intercept is here. And so that is the point 0, 1. Again, x first, it doesn't move left or right, it goes up 1. And finally, our rate of change, please change that to x equals 1. I can't see x equals 2 on this graph, so we wouldn't really know what that is. So let's find these points. At x equals 0, we're at 1, so that's the point 0, 1. At x equals 1, we're at 4. Again, remember your range is, our rate of change is y minus y over x minus x. Average rate of change is asking the same thing as when you find slope. Okay, so average rate of change, slope, those are the same exact thing. So y minus y, we take 4 minus 1 over 1 minus 0. 4 minus 1 is 3. 1 minus 0 is 1, which equals 3. And that's it. So now let's look at example 2. Now I'm looking at our logarithmic function. It's the same one, right? They have the same base. This is if I switched it into exponential form, right? Kind of solve that. Okay. So then we start with our domain. Now for our domain, if you look, we have this lovely vertical asymptote. And same thing as before now, but on this side, this is where we have nothing, right? No part of my graph is over here. So my domain starts at 0 and goes to infinity. My range, if I start on the bottom and travel up, right, there's nothing stopping my range. So my range is negative infinity to infinity. I'm going to treat this as it doesn't have an y-intercept. We really want our x-intercept when we're talking about logarithmic functions. So our x-intercept is here. That is at 1, 0. And now our average rate of change from x equals 1 to x equals 4. Well, at 1, 0. At x equals 4, we're at 4, 1. So again, average rate of change is y minus y over x minus x. So y minus y, x minus x. 1 minus 0 is 1. 4 minus 1 is 3. We get 1/3. So if we look at the relationship between these two things, right? Domain and range. If you look at your domain here, or domain and range here, and domain and range here, you can see they're just flipped. So the domain of this first function, I'm just going to make it smaller, the domain of this first function is the range of the second function, and the domain of this is the range of that. Our y-intercept and our x-intercept, they just flipped, right? The x and the y just flipped. Rate of change here, rate of change here, again, they flipped, okay? So these inverse operations have similar, but again, inverse or opposite properties. Let's look at another example. Okay. We're going to use our calculator to get these. So I'm going to use my calculator. I'm going to go to a graph. I'm going to go 4 times 2. Sorry. Exponent. X plus 1. Right? We're going to get that graph. Okay? The easiest way to graph these with here is then to go to Menu, Table, and split screen the table. Okay? That way I can start, and I want to start with like, if I scroll here, I don't want to do decimal, so we'll start with -3. That's usually what I do. So it's -3, 1. -2, 2. Yeah, come on. -1, right? 4. 0, 8. 2, that's off the graph, right? So eventually they go off. Ooh, make a nice line straight up there. Okay, so that split screen table, again, how you get to that is if you're here, you just go to Menu, that's 7, and that's your split screen table, okay? And then you could also remove the table later on if you're done with it, and you can kind of just look at the graph. So we have this beautiful graph. Let me get full screen again. So let's look at our different things. We have domain, range, y-intercept, and average rate of change. So our domain, again, going across our x-axis, right, never stops. Our domain of this function is still -infinity to infinity. For our range, right, this is our horizontal asymptote. There's nothing down here, so it's just going straight up from there. So this is from 0 to infinity. Our y-intercept this time is at 8. So that's 0, 8. And our average rate of change from x equals 1 to x equals 4, I want to know what these values are. So again, I would go to that table, so Menu, 7, split screen table. At 1, it's at 16. At 4, it's at 128. Okay, so I just use that table to find these. The other thing you can do is plug it in. Okay, so 1 plus 1 is 2. 2 squared is 4. 4 times 4 is 16. 4 plus 1 is 5. 2 to the 5th is 32. 4 times 32 is 128. Okay, so there's two ways to kind of do those. Then we are still doing y minus y over x minus x. So we have 128 minus 16. And we get 112 over 3. I believe it just stays like that. I don't believe that. Okay. Does not reduce or anything. Or, it's not going to reduce anyway. But I did do it the wrong way. Okay, so 112 over 3. All right, we're going to do example 4 in class. Again, practice some of those calculator things. And all of that when we have a calculator. Okay, so just go ahead and jump down to example number 5. All right, so looking at example 5 and 6, these are just some quick word problem, rate of change problems. So the energy magnitude M of an earthquake can be modeled by M equals 2/3 log of E minus 9.9, where E is the amount of energy released in ergs. Right. Find the average rate of change between 10 ergs. So that's E equals 10 and 1,000 ergs. So it's E equals 1,000. Okay. So you could graph something like this and use that table. The other thing you could do is just plug it in. So M equals 2/3 log of, instead of E, I'm going to plug in 10. Minus 9.9. And I'm going to type that into the calculator portion. So we have 2/3 log, oops, make sure you hit control first, control log. This would be base 10. You also don't have to put anything. If it's a common log, you don't have to put a base. Minus 9.9. We get negative 9.23. I'll go to hundredths. Then our other one is M equals 2/3 1,000. Again, I'll do that again. I do these quick things. You can always, when you're doing something like this, where you're plugging the same number in over again, if I just hit the up arrow till it's highlighted and hit enter, it allows me to just change quickly the 10 to 1,000, and I don't have to worry about typing the whole thing again. It's a really nice, quick way to do that. And we get negative 7.9. So those are my 2 points, 10, negative 9.23, and 1,000, negative 7.9. So now, our y minus y over x minus x, I have negative 7.9 minus negative 9.23. Again, there should be 2 negatives here. Over 1,000 minus 10. I'm not going to try and do this one in my head. So I'm just going to hit control divide. It doesn't like my control. Where's my mouse? Control divide. And we have negative 7.9 minus, right? We need minus and the negative sign, 9.23 over 10,000 minus 10. We get 0.001343. Alright, last problem, same type of thing. A biologist can estimate the age of an African elephant by measuring the length of its footprint and using the equation L equals negative 25.7 e to the negative 0.09. It's supposed to be a in there. Got a space instead of an A. A plus 45, where L is the length, and A is the age in years. Okay. It's like problem did. Let's do rate of change between A equals 2 to A equals 8. So L equals negative 25.7 e to the negative 0.09 times 2 plus 45. So I'm going to type that in my calculator. Move it back over. So we have negative 25.7 e. So this is always, there's this e to the x right here. So you could just click on that. Negative 0.09 times 2 plus 45. And we get 23.5 centimeters. Same thing for the other one. L equals negative 25.7 e to the negative 0.09 times 8 plus 45. And then I want to just change this 2 to an 8, right? So I can do that, just highlight it, hit enter, trick again, and we get 32.5. Okay. So our rate of change is y minus y over x minus x. These are our two y's. It's supposed to be a 5. So I have 32.5 minus 23.5 all over 8 minus 2. This one I feel like I can do. 32.5 minus 23.5, that's 9 over 6. Right? Which, if you want to reduce it, it's 3/2, so 1.5. Okay. So they gain, if you want to think about it in words, they gain 1.5 centimeters each year, okay, in their footprint. And that's it.